So, hi everyone, welcome to the first live session of the course on measurement and instrumentation. We have got several questions and we'll try to take all of them one by one. All right. So, yeah, the first question was, what is the meaning of luminous intensity? Give me an example. All right, so let's try to understand the luminous intensity. Okay, and we'll try to understand with not an example, but with two to clarify it. Okay, so luminous intensity is the amount of visible light emitted by a source in a particular direction. Please note this word, particular direction. We will be sorry for the glitch. So we will be discussing this luminous intensity. So as I was mentioning, luminous intensity is the amount of visible light emitted by a source in a particular direction. So this direction is very important here. Okay. So when I say luminous intensity, it actually describes how bright a light source appears when you see it from particular direction. Okay. So it's a fundamental photometric quantity, means it is weighted according to the sensitivity of the human eye. Okay. And the SI unit of luminous intensity is candela, that we have also discussed in the course. But ultimate aim of today's doubt clearing session is to understand luminous intensity like a layman. Okay. So the luminous intensity actually tells you how bright a light appears when viewed from specific angle. Okay. So the angle also play a very important role, and in the formula of calculation of luminous intensity, we'll see that how to include this angle also mathematically. But let's try to explain it first from theoretical perspective. Okay. So luminous intensity, how bright a light appears when viewed from a specific angle, not the total light output, but the directional strength of light. Okay, because directional strength of light is sometimes very important for us, and sometimes the intensity and other things overall, if you see in all the direction, may not be that important for us. Okay. So in more scientific way, we can define luminous intensity as the amount of visible light power emitted by a source per unit solid angle in a given direction. Okay. So the unit, as I have mentioned, is candela, and one candela represents a defined amount of visible radiation emitted in a specific direction. So with example, let's try to understand this. So I have taken example of two things. Both are light sources. So the first is a light bulb, okay, and second is a torch, okay. If you see this bulb, it is spreading light in all the direction, okay, and if you try to calculate the luminous intensity in any particular direction, you will find it lower, okay, and of course, this is better for lighting a room, but if you want to have a long distance visibility, it may not be that significant. But at the same time, if you see a torch, okay, the emission of light is in narrow direction, okay, and it has high luminous intensity, and it appears very bright when pointed at you. So if both the things have say same luminous intensity, or say same luminous, okay, then also the one which is having higher luminous intensity will appear very bright if you see in that particular direction. Okay. So that's how car headlights are also designed. So car headlights are designed with reflectors and projector lenses to increase luminous intensity forward, allowing drivers to see further without wasting light sideways, right? So in nutshell, if I would say, I can say that luminous intensity is something where you are dealing with the light intensity, okay, in a particular direction. So basically, it's the flux at per unit solid angle. Okay, so luminous intensity I, whose unit is candela, is equal to luminous flux phi, which is in lumens divided by solid angle. The unit of solid angle, all of us know, is the ST radian, right? So this is how luminous intensity is defined. All right. So I hope that concept of luminous intensity is clear to you. Okay. I have tried to explain it with one example. Now, another question was, what is happening in this video at particular time? And there I was discussing basically week 4 of our course overview, where I was talking about analog meters. Okay, so I will give you a brief overview of the course once more, and I will emphasize on week 4 so that this doubt is clear. Okay, so I have divided this course over 5 different modules. Okay, and the first module of or first week, if you say, of this course, deals with the first module of the course, which is the fundamentals of measurement systems, right? So in this, I hope that till now you have already covered this. Here I have talked about different type of measurement system, then characteristic of measurement system, and mostly the characteristic we have seen from the perspective of static characteristics and dynamic characteristics. We have also seen measurement uncertainty, loading effect, and so on. Okay. The second week onward, we have focused on analog meters, and I have mentioned that analog meters is the longest module in our course. Okay, and here I have started with a basic introduction to analog meters, and then we have done certain classification of analog meters based on different effects. So we have seen that these analog meters are based on different effects, be it magnetic, electrostatic, thermal, and so on. Okay, and we have categorized certain instruments based on these. So for example, we have classified, say, PMMC, moving iron, and so on based on magnetic, and then we have electrostatic systems, we have electrodynamic systems, and so on, right? In the third week, we have talked about the generic, operating forces in electromechanical indicating instrument and the construction of a electromechanical indicating instrument we started. Okay, and then we talked about a voltmeter and ammeter. Okay, at least I have given certain introduction. From week 4 onward, which was the doubt of the student, we will be talking about permanent magnetic magnet moving coil, or PMMC instrument. Okay, and then moving iron instrument, and then electrodynamometer instrument. Okay, so the question was about this overview. Please note that this is just an overview. You will be studying all these instruments in detail in coming lectures. Okay. So here we will be talking about operating principle of PMMC, moving iron, electrodynamometer instrument. All right. So basically, if you see these instruments are like what do you say? Permanent magnet moving coil instruments. Let me take a pen, okay, then we can discuss. So if you see, you have already seen that all these instruments are made up of 3 things. Okay, say first is the deflecting system. So deflecting systems, right? So where basically these system provide you with the deflecting torque, right? Then you have controlling system, right? Controlling systems. And then we have the damping system. I hope that you remember these 3 systems. in the construction of any electromechanical system, right? So deflecting system, controlling system, and damping system. Okay. Now, depending on what kind of instrument it is, like if it is say permanent magnet moving coil, okay, you will have the different element working as a deflecting system, then different system for controlling and different for damping. Similarly, for moving iron, you have distinguished three components. Similarly, for electrodynamometer instruments, you have different difference in the deflecting, controlling, and damping, right? So I think based on these things, the distinctions are there among them. Okay, and we will also see in this course that which kind of instrument is suitable for what kind of application. Like PMMC is suitable for say measurement of AC quantity or DC quantity, or say moving iron is suitable for measurement of AC quantity or DC quantity, or they can be measured, they can be used for measurement of both the quantities. So ultimately, aim of this overview was like this. Okay. I hope that this is clear to you. Similarly, for week 5, we have different analog meters to be discussed that are say mostly thermal devices like hot wire, then temperature devices like thermocouple, induction type of instrument, electrostatic tools, rectifier type of instrument, and so on. Okay. Again, week 6 is also devoted to analog meters, where we will talk about measurement of different quantities, including measurement of resistance, power, and energy. We'll be focusing on measurement of resistance, and you will see that we have divided the resistance in 3 different ranges, where we have low resistance measurement techniques, then we have medium resistance range measurement techniques, and then we will all together employ different kind of approach for measurement of higher resistance. When I say higher, means a certain mega ohms or giga ohms kind of structure, right? Then similarly, for power and energy, we will see separate meters, okay? Because you know that power you can calculate by simply by multiplying the voltage and current. Similarly, energy, you can integrate this power, but then there are few terms like power factor. So power is basically for AC signal, it is VI cos phi. So if you simply try to multiply these factors, you may not able to get, because the power factor is missing, right? So we will see specific tools which can measure power, and then it will integrate it over time to give you the energy values. Okay. So basically week 2 to week 6, we are devoting to analog meters. Okay. And then you will start learning about different transducers from week 7. Okay. We will see first different characteristic of a transducer, and many of the transducer characteristic you will see will be overlapping with our week 1 discussion. So it will be very easy for you to understand, and we'll see that how to utilize this transduction technique to measure certain physical parameter, including temperature, pressure, force, strain, and so on. Okay. So in the discussion, we'll talk about strain gauges, we'll talk about temperature detectors. In temperature detector also, you will see that how a simple resistance, can be used for the measurement of temperature, and it is being employed, deployed by the industry also. So you will see that a simple resistor, say metallic resistor, okay, can be used, for the measurement of temperature over the wide temperature range. Okay, say anything from minus, say 100 degrees Celsius over 600 degrees Celsius, and so on. And for the measurement of higher temperature, even you can utilize that, but then you have to change the metallic component and so on, right? See in detail that how it can be used for measurement of force and pressure and so on. Okay. Week 9 is devoted to signal conditioning, and there we'll mostly learn about instrumentation amplifier, different filters, including different active and passive filters, linearization, okay, and maybe some part we may also learn about power supplies, okay, for these transducers, okay. Then week 10 will be devoted to shielding and grounding and ADC and DAC for the devices, okay, for the transducers. Week 11 is mostly dedicated to data acquisition system, where we'll talk about digital meters and analog and digital oscilloscopes, okay. Week 12, which is our final week for this particular course, we'll continue our discussion on data acquisition system, where we will learn about PLC, programmable logic controllers, harmonic distortion, and spectrum and logic analyzers. Okay, so this is I hope that there should not be any doubt in this course overview, because if you understand that what you are going to learn, it becomes very easier task to learn these things. Okay, so it should be very clear that what we are going to learn, what will be the output of this particular course. Okay, particularly week 4, which is very, very important in this course. I hope that your doubt is clear. Okay. Then there was a question about this particular slide that deals with elements of measurement system. Okay, and this is what we have seen. Okay, measurement. This is a typical elements of measurement process. Okay, you have a measured variable. Okay, this is measured variable, or we called it measurand throughout the course. You have a sensor, or whatever you want to call, maybe transducer. Then you have variable conversion elements. Then signal processing, including signal processing, including signal conditioning, and everything is included here. Okay. Then signal transmission elements. Then signal presentation or recording, and that's how you see at the output. And I discussed that you had a measurand, which is the physical quantity you wish to measure. It can be anything. It can be simple temperature, it can be pressure, and so on. Okay, then you have a primary sensor which produce output in function of measurand. So you had certain output here. Okay, then you have a variable conversion element which convert the sensor's output into the useful signal format. And please note that this useful signal format is for next stage, which is basically signal processing plus, say, signal conditioning. Okay. Now you have a signal processing and conditioning stage, where you do signal quality improvement using various techniques, and then you have transmission and then presentation or recording of this data. Okay. Now the second question from this, which is very, very important, and I would like to clarify this in this particular live session. The question is, the signal conditioning is of smoothing the signal, whereas the signal processing is of I don't know. Okay, now this is the question, and this is a very, very valid and logical question. And today, let us try to understand this in little detail. Okay, now please note that whatever you have mentioned, that signal conditioning is of smoothing the signal. Okay, now this sentence itself is not fully correct. Okay. Now you cannot say that signal conditioning is only smoothing of the signal. Okay, you can say, of course, that when you say smoothing means that you are kind of filtering one part of the signal. Okay, so you can say that smoothing or filtering is partially it is signal conditioning, or it is a part of signal conditioning, but then signal conditioning include other things also. Okay, so signal conditioning refers to all operation performed on a sensor's output before further analysis or digitization occurs, so that the signal becomes usable and reliable. So this includes, but not limited to, say, amplification. Okay, increasing the signal level, then filtering or smoothing that you are telling, mostly removing the noise and other things, and then you have the variable conversion. which was the step in our measurement system also. Okay, so conversion of say resistance to voltage, or if the output is in terms of voltage, and say the subsequent stage require current as a input. So conversion of resistance to voltage, or say voltage to current, and so on. Okay, and then isolation and linearization. So these are some of the ways of signal, signal conditioning. Okay, but please note that signal processing is a little different. So signal processing deals with analyzing, modifying, interpreting, or extracting information from the conditioned signal. Okay, so it includes signal analysis. It can be theoretical analysis, so time in time domain or frequency domain, then feature extraction, then modulation, demodulation, then digital processing, including FFT, averaging, detection, compression, and so on. Okay. So, however, in this elements of measurement system, since I was showing you in a crude way, I have not included signal conditioning separately, but of course, these step also include the signal conditioning separately. Okay. So if I see the difference between signal conditioning and signal processing, please note that this is say signal processing. Okay. So this is processing. All right. So signal conditioning refers to the process of preparing a raw sensor signal so it can be accurately measured or converted. Okay. So here you are dealing with the raw sensor signal and you are preparing it, for the accurate measurement or for accurate conversion. While signal processing is the technique of analyzing and interpreting the conditioned signal to extract meaningful information. Okay, so here it is dealing with the conversion while it is dealing with the extraction. Okay, so main purpose of signal conditioning is to make the signal clean, stable, and usable, as you have also pointed out regarding the smoothing. Okay, so main purpose of signal conditioning is to make the signal clean, stable, and usable, while the common operation of signal conditioning include amplification, filtering. When I say filtering, means removal of noise, drift, and so on. Okay, then isolation, linearization, and analog to digital preparation. Okay. However, you can also understand this with certain example, like a thermocouple produces say output in millivolt. Okay. Now it has to be digitized, so it will be first amplified, then it will be filtered for any noise, and then it will be sent to ADC. So these are the steps involved in the signal conditioning, right? Then signal processing is the technique of analyzing and interpreting the conditioned signal to extract meaningful information that we have just seen. Okay, and the main purpose of signal processing is to turn the signal into useful data or take decisions. Okay, and the common operations include Fourier transform, noise reduction algorithms, data compression, pattern recognition, feature extraction, and so on. Okay. So if you see the major difference between a processing of the signal and the conditioning of the signal, at the first stage, okay, signal conditioning is happening while signal processing is taking place after this signal conditioning stage. Okay. Now the goal of the signal conditioning is to prepare the signal for the next stage. Okay, while signal processing is mostly dealing with the extraction of the information. Okay. Now, signal conditioning is mostly done through hardware implementation, while signal processing also requires certain software skills. Okay. Now, signal conditioning is also dealing with the signal quality, like if you have noise, if you have to do amplification, and so on. While signal processing mostly deals with the meaning of the signal. Okay. So, to interpret the meaning of the signal. Okay. Then signal conditioning, as I have mentioned, there are different stages like amplification, filtering, and so on, while signal processing include FFT, digital analysis, and other things. Okay. Now, there is another question which is linked with the previous one, which is A variable conversion elements also known as signal conditioning element. Is it true or not? Okay, and this was the question in 4A also. Okay, 4A and 4B are posted together. Okay, so this variable conversion element, if you are those who could not follow, okay, this is the student is basically talking about this variable conversion element, right? That I have shown as a part of our measurement system. Okay, and for this I would say that yes, a variable conversion element is commonly treated as part of the signal conditioning stage, but with a specific role. Okay, so a variable conversion element converts the output of a sensor from one form to another more useful or convenient signal form, usually without adding any additional energy. So its main purpose is to make the sensor output suitable for further processing or measurement. So it will depend on what is the next stage in case of this measurement system. Okay, so it changes the nature of signal, but necessarily it may not be changing its magnitude. Okay, so the example can be like converting a resistance change into a voltage signal. Okay, similarly change in the charge flow to voltage signal and so on. Okay, so yes, you are very much right that variable conversion element can be treated as the part of signal conditioning stage. Okay, then there is another question that what is happening in this video at time this particular thing, and this is the slide that I was discussing at this particular moment, where I was discussing about different modules of this course. Okay, if you have still doubt about different modules, I would again repeat that this course is built up of 5 different modules. Okay, first is the fundamentals of measurement system. Then we have analog meters. Then we have transducers. Okay, whatever knowledge we have gained in our first module can be implemented across analog meters and the transducers, particularly the static and dynamic characteristic and so on. Okay, and then we have 4th and 5th module mostly dealing with the signal conditioning and the data acquisition systems. Okay, so now so it covers most measurement system, transducer, conditioning circuit, and so on. The subject course emphasizes accuracy, precision, error, and calibration to ensure reliable measurements wherever the things are desired. Okay, now these fundamentals are essential for monitoring several things, including control, automation, and other engineering systems. Okay, so I have given you today also regarding the details of analog meters and what kind of meter we are going to discuss. Okay, similarly, I have also given you an overview that what kind of transducers we are going to learn. Okay, to measure different physical quantities, including temperature, strain, force, pressure, and so on. And of course, these transduction techniques will be based on certain, physical conditioning. Like you may have a transducer based on capacity principle. You may have another transducer which might be based on some resistive principle. Then you have transducers which are based on certain magnetic phenomena and so on. So we are going to learn all these techniques in this particular course. Okay. Then another question was regarding the error, particularly the instrumental error. So if you recall, we have seen different type of errors in this course. We have seen that errors can be due to different sources, and they are classified under 3 different heads: gross error, systematic error, and a random error. Okay. Gross error we have seen already, and systematic error also we have seen that they can be divided into 3 different categories: instrumental error, environmental error, and the observational error. Right? Now, among these, instrumental errors can arise due to 3 main reasons again: due to the inherent shortcoming in the instrument, due to misuse of the instrument, and due to the loading effect of the instrument. And I think that this was exactly the doubt, that how these errors arise and what do you mean by inherent shortcomings, what do you mean by misuse of the instrument, what do you mean by the loading effect of the instrument, right? So to counter that, let's try to understand it, all these 3 points in little brief. Like first is due to inherent shortcoming in the instrument. Okay. Now this inherent shortcoming may be due to construction, it can be due to calibration, or sometimes it can also be due to operation of the instruments. Okay. Now these errors may cause the instrument to read either too low or too high, and the instrument may be at least recalibrated to minimize it. Okay, so you cannot make it zero, but at least you can minimize by doing the recalibration. Say, for example, if the spring, which we know that it's very important for producing control torque among all the analog tools that we have seen. Okay, so if the spring of a permanent magnet instrument has become very weak, the instrument will always read high. Okay, so this is just one example, but error can be due to many things. Many inherent shortcoming of the instrument, maybe because of friction, because of hysteresis, and other things. Okay. Now, the second cause of this error is due to misuse of the instrument. Okay. So error caused in the measurements are due to the fault of the operator rather than that of the instrument most of the time. Okay. So a good instrument used in an unintelligent way can give you erroneous results. Say, let's try to understand this with one example. Like if you have, say, say voltmeter, okay, this voltmeter reads very accurately from 100 to 200 volt, okay, very accurately, okay. Now you have another voltmeter, say microvoltmeter, which can read say 1 to 10 microvolt, okay. Now you want to measure a voltage, say 5.378 microvolt. All right. Now, in this case, if you have both these voltmeters, and then also if you are using this, it means that you are using your voltmeters in an unintelligent way. Okay. So if you have requirement of this kind of accuracy of 5.378, you should always use this voltmeter, because this will have a better accuracy, particularly for this particular range. So as an end user, we should know that what is our requirement, and accordingly we can choose the instrument. Okay, there can be other examples also, like a failure to adjust the zero of instrument, or say poor initial adjustment, and so on. Okay, now the third shortcoming is the loading effect. Okay, so a well calibrated voltmeter can give you a misleading voltage reading when connected across a high resistance circuit, and this is because at this particular point, the resistance of the voltmeter and the circuit are comparative, and the voltmeter can draw significant amount of current from this high resistance circuit, right? So if it is drawing certain kind of current, it means that the result will definitely be erroneous. Okay. Now the same voltmeter, when connected to a low resistance circuit, can give a more dependable reading, because at this particular point it is ensured that since voltmeter has higher resistance as compared to the low resistance circuit, it means that it is not loading the circuit and it is not drawing any significant amount of current from the low resistance circuit. All right. So therefore, loading effect is very crucial for correct results. Okay. Now these examples illustrate that the voltmeter has a loading effect on the circuit, so altering the actual circuit conditions by the measurement process. So you should choose your instrument in such a way that it doesn't load the already existing circuit in which you are attaching it. All right. Then one more question was, kindly explain how higher reluctance yeah. So kindly explain how higher reluctance enhances the sensitivity of the galvanometer, making it more responsive to small currents. Okay. And this was, from the galvanometer discussion, where we have seen that magnetic reluctance is like resistance in a magnetic circuit, and the reluctance was given as L by mu A, where L was the length of the magnetic path, while A was the cross section and mu was the permeability. And we have seen that air gap has very low permeability, so adding air gap is highly increasing the reluctance in this case. Okay. Fine. So in case of galvanometer, I will not go in the construction of galvanometer. Okay. But I would rather directly go to the influence of the air gap. Okay. So the air gap introduces high reluctance, that you understand, which is causing the magnetic flux to concentrate in the gap and form a strong uniform radial magnetic field in the working region of the coil. And you can understand this with the analogy of water flowing through a narrow pipe. So when water is flowing through a narrow pipe, it becomes fast and concentrated. And exactly that thing is happening here, that this strong magnetic field increases the deflecting torque even for a small current. Okay. And that's why, in case of, when you have high reluctance, your sensitivity is also increasing. Okay. So when you have this strong magnetic field, it means that you have higher deflections even for a small current. Okay. And it means that when you have higher deflecting torque, means that there will be larger deflection, and of course then you will have a higher sensitivity of the galvanometer. So sensitivity we have already defined as theta by I or NBA by K. So you can understand that when you have higher reluctance, means that at the same time you have a better sensitivity. Okay, so these were questions that that were posted. Now there are three more questions. That is something we wanted to take. Okay, now the question was, I want to take advantage of automation in my agriculture fields as a agripreneur. Can your course and you help for this particular objective? Okay, so thanks, Alok, for this particular question. Of course, if you are an agripreneur, you might be knowing about precision agriculture. Okay, and for precision agriculture, it is very, very important to know about measurement and instrumentation. I hope that this course will definitely give you an overview of different measurement system. But if you talk about specific tools, like for example, say NPK sensor, I know that I understand, or I assume that you might be knowing about NPK sensor that is required for agriculture, okay, or particularly for soil. Okay. Similarly, you have other sensors, like you have to check the soil humidity, you have to understand the nitrogen loss, okay, and other things. Okay. In my opinion, this will be helpful for you to understand the basics of the measurement system, but then you have to go one step ahead also and try to understand these sensors also. Of course, our group is also working on different agriculture sensors, and it's not that we are starting new. We have been working on in this domain. Okay. So of course, we will be able to help you. You can drop me a personal email and then we can connect, then another question is, which is a little difficult for me to understand, sir. I think this is student has tried to write something in his own language, which I'm not able to understand, but that's okay. You can post it, Rama, you can post it later also in our second interaction. We may take that. If I understand it You can translate. I mean, language is not a barrier. You can translate it, using a Google Translator or any other translator to English. Okay, so I understand two languages, Hindi or English. So you can translate it and post. I will definitely try to answer that. Okay. Then another question is what skill and technical areas should a student focus on to build a strong career in the field of electrical and electronics engineering? Okay. Now, Dhanush has posted this question. Okay. And Dhanush, I'm not aware that you are in which standard. I mean, are you? I mean, you are in second year student or third year student or first year student or you are a MTech student. I'm not aware of, but in general, I could say that electrical and electronic engineering, is a fascinating field of research, and for making career, it is very much suitable. You can, I work in the sensors domain, so I could definitely say that these sensors are, or this instrumentation is one of the area which is very hot. Okay, particularly in the rise of IoT and other kind of devices has made it very much, career oriented. If you see, if you take an example of particular, say a sensor, it requires a number of skill, right? You require to fabricate these sensors. So you require skills to fabricate these devices. You require skills for backend electronics. Okay, you require skills for processing the data or signal processing. Then you require, any industry will require analog and digital engineers. Okay, so I think analog engineers or say, circuit designers. These are some of the areas which will never go old. Okay, every time any company design a new microcontroller processor, they will require help of these circuit designers. Then you have people who develop EDA tools. Okay, then you have people, you have requirement at the signal processing end. Okay, and so on. Okay, I think this career in this electrical and electronics engineering department is huge. You can definitely bet on it, and I'm sure that this career in this domain, will take you to a newer height. I think with this, we have discussed all the questions, and I have taken all your questions. We will, if you still have any doubt, you can again post it, and we will take it maybe in our second live session. So with this, maybe we would like to close this particular session, and you are always welcome with all your doubts. And in this kind of session, we will keep on meeting. I hope that you are enjoying this course thoroughly, and not worry much about scoring and all. You will score well only because the course has been designed in such a way that students get benefited. Okay, the course is not designed in such a way that to make it difficult. Okay, the ultimate aim is to reach out to you with whatever way we can simplify this particular course. I hope that we will meet again with with more questions and more discussions. Thank you.